So, differential equations, we've done some in the past, but not to the degree that we're going to do now. But they're an equation that involves the x, y, and derivatives of y. So the way you solve them is you separate the variables, you integrate, you find the general solution, and then you use given information to find the initial or particular solution. So we're going to do an example of how to do differential equations. And so let me write this the first example. We will have dy dx equal 2y minus 1. So this is our differential equation. Now to solve it, you want to separate the variables. So you want to get the x's on one side and the y's on one side. So first thing I'm going to do is multiply both sides by dx. So I get dy equal 2y minus 1 dx. Now I'm going to divide this 2y minus 1 to the other side. So if I do that, I'll have 2y minus 1 dy equal dx. Once I've got them separated, now I'm going to integrate both sides. So here I'm going to do u substitution. U equal 2y minus 1 du will be 2 dy. So if I negate it, I'm going to have 1/2 the integral of 1 over u du equal the integral of dx, and that'll be 1/2 ln, and my u was 2y minus 1 equal x, and you put the c just on one side. You put it on the side with the x. You don't need to put it on this side, because if you had a constant on this side and took it to this side, they would just combine. So I want to solve for y. So the first thing I'm going to do is multiply by 2. So I get ln 2y minus 1 equal 2x. And I don't really need to say 2c, because again, it's just representing a constant. So c or 2c would be the same thing. Now, how do I get rid of ln? I take the e of both sides. So when you do that, you end up getting 2y minus 1 equal e raised to the 2x plus c. Now here's the key on these type of problems when you have an e. Think about algebra. This is the same thing as e to the 2x times e to the c. Because remember, when you multiply, you add exponents. Well, what does this do for me? E to the c is just a constant. So I can write this as 2y minus 1 equals c e to the 2x. I can bring this out front. And that's what you do with all of these type problems. So then I'm going to have 2y equals c e to the 2x plus 1, and then divide by 2. And then my general solution is this. Now, if they give you values to get a particular solution, then you can plug it in and get your value, which we'll do one of those in a minute. So this example, we've got 1 plus x squared dy dx minus 2xy equals 0, and we want to find the particular solution when x equals 0, y equals 2. So our first thing that we want to do is to take the 2xy to the other side. So I added it to the other side. Then we want to multiply both sides by dx. So when we do that, we end up with this. Now, we want to get the x's and the y's separated. So first I'm going to do is I'm going to divide by y on both sides. So if I do that, I end up with this. Now I'm going to divide by 1 well, I'm going to multiply by 1 over 1 plus x squared, so that'll cancel out. So if I multiply both sides by 1 over 1 plus x squared, I end up getting this. So now my variables are separated. So now I can integrate. So if I set up my integrals, I get this. And then, of course, I'm going to have to do u substitution for this side. So u equal 1 plus x squared, du will be 2x dx. So I'm going to end up getting ln of y, because that would be the integral of that. And then the integral of 1 over u would be ln of this plus my c. So now I'm going to take the e of both sides. So I'll take the e of this and the e of this. Now remember, I can break this up as e this times e to the c. So I can go from here to here, so that means this is going to come out front. And when it comes out front, it's just a c, and my e and my ln canceled out. So I have this as my general solution. Now to get my particular solution, I plug in the values they gave me for x and y, and I get that my c is 2. So my final answer would be y equal 2 times 1 plus x squared. So here's another example, xy plus y prime equal 100x. So I'm going to write that as xy plus dy dx equal 100x. And we're going to take the xy to the other side, and we get 100x minus xy. Then we're going to multiply by dx, so we get 100x minus xy dx. Now we want to pull x out as a GCF. And so we get dy equal x, 100 minus y dx. And so now we can divide this 100 minus y to the other side. So if you divide that to the other side, you end up getting 1 over 100 minus y dy equal x dx. And then we're going to integrate. So when we do that, we're going to do u substitution. And you get du equal dy. So we're going to do negative 1u du equal integral of x dx. And when you integrate, you get negative ln 100 minus y equal 1/2 x squared plus c. Divide by your negative and take the e of both sides. So we're going to take the e of both sides. When we do, this cancels out. We get 100 minus y equal e to the negative 1/2 x squared. That's a multiplication sign times e to the c. So remember, this is a constant, so we can bring it out front, subtract our 100 over, divide by negative, and this is our general solution. Now let's look at another example. We've got y prime minus 2 e to the x equals 0. So y dy dx, I'm changing that, minus 2 e to the x equals 0. I'm going to take this to the other side. I'm going to multiply by dx. Then we're going to integrate. When we integrate, we get this. Then we'll multiply by 2 to get this. And then, so after we multiply by 2, we get this. I'm going to plug in my 3 from our initial condition, 0 for my x initial condition. My c becomes 5. And then I take the square root, and this is my particular solution for this problem.